Hello and welcome to another exciting Breakfast with Unity. I'm your host Max Moreau, and today we're going to be working a little bit more on the Projectile Path system. So, Unity's not open. Great. Hold on. Just one moment here. So what we did last time is we had some projectile stuff where we drew a path of a proposed projectile using a script and a line renderer. And as soon as this is done, why is it taking longer to import? That's silly. All right. But anyway, what we're going to be doing today is we're going to make it so that if it intersects a point, it's going to show where it's going to explode. And I'm also going to try and set it up so that if you throw it up into the air, it'll show where it'll air burst as well. So we're just going to kind of play around with that and actually hook it into a system that has a grenade so that we can verify that it works properly. Sorry about this. All right. So, Ballistic Path. So what we have right now is, if we hit play, we have this this line renderer that will render a path of a ballistic object. We're doing this by using the physics calculations for gravity and velocity. We're not doing anything with drag or anything, so if you apply drag to a rigid body and you expect it to work with this, you're going to have to add a drag component. We're not going to cover that right now. So we can increase the velocity of the projectile, and we can change the angle that we launch it at, and all of this works as you would expect. So it's awesome. So what we're going to do now is let's first hook it up so that we actually have a thing to blow up. So let's just create we're going to create a plane to stand on. We're going to make it 10 by 10, which actually makes it 100 by 100 because the default plane is 10 units on each side. We're going to set it to 0, 0, 0. I'm going to add our first-person character controller into the scene. We're going to remove the main camera here, and we'll put this somewhere near 0, 0, 0, and I'm going to create a directional light 0 and 0. We'll put this at 2 units up so that it will fall into the scene properly, and we'll go ahead and this is the light. I don't care about where the light is. As a matter of fact, let's make the light go 100 so that we don't have to see it in the scene. And we're going to go to the first-person controller and set it to something reasonable. 0, 0, and 2. So if we hit play right now, we'll have we can actually see the path that we've drawn here. And actually that looks way better than I thought it would coming in forward. So we'll probably just have this offset to the right a little bit like that. That's awesome. We're also going to make the path considerably smaller. So let's go ahead and fix that real quick. In our game object, I'm going to call this our path example. We're going to what are we doing? We're going to make this thinner. So start width is 0.1 and end width is 0.1. So if we hit play, might even want to start width and end width differently. So yeah, we can see that this is already looking real. Oh, that's looking real good. So yeah, I wasn't expecting it to look that good, actually. We probably could change the resolution of this to be a little bit smaller, but, it's actually probably pretty good. So what we need to do next is we need to actually have this, check for an intersection, for figuring out where it's going to explode. Actually, let's hook it up to the character first. But the reason we need to check this, I just want to show you, is this path goes 4 ways. We have it set to 10 seconds, so it shows the full 10 seconds of a ballistic projectile. And so 10 seconds later, this would show up underneath the world, assuming that it didn't hit anything, which of course it's going to hit something, which is why we're going to use impact grenades, so we don't have to deal with the bounce case. Impact/time grenades. We're going to do a combo grenade. So let's first just go ahead and hook this script into, I'm going to copy component, and we're going to paste it, actually I'm just going to put this object in here, so we'll just call this Ballistic Path. Ballistic Path. And we'll throw this into our first-person controller under the main camera. So if we have this rotated to 0, 0, 0, and we have it in the exact same position as the camera, this thing probably will look a little odd. Oh, no, it's actually not as bad as I thought it would be. That's actually pretty awesome. So we've got it here, but I'm going to offset it to the right. So we're just going to move it to the right by about, I don't know, 0.33. Let's see how that looks. It's looking pretty good. This is 16 by 9. That'll work. So this will be 0.33 off of where it's actually landing, but I think we can live with that. The other thing I'm going to do is I'm going to make it so that the ballistic path has a little bit of an angle to it initially. So we're going to angle it up so that we're firing at about, let's do 15 degrees up. See how that looks. Let's make it a little bit stronger throw too. So currently we're doing an initial velocity of 10. We're going to do an initial velocity of 20. So now we can hit something close or something far, potentially very far away. Cool. All right. And actually I'm going to, let's do 15 and make it a little bit higher on the, or let's see, just negative 25. Just playing with it a little bit. There, that looks like a pretty useful range. You can throw it close and you can throw it far. All right. So let's make our little projectile thing. I'm going to save what we've got so far real quick. And we've already done projectile stuff before for our ballistic targeting, so I'm going to steal what we did back there and tweak it so that it works. So right now, on our main camera, we have a spawn on button and we have a grenade. So I'm going to use spawn on button and I'm going to duplicate this grenade and put it into our new folder here. I'm just going to rename it to grenade. And what are we doing? We're going to reopen our ballistic path. We're going to add a spawn on button. I'm going to actually add it to the ballistic path itself. The reason being is this has the angle that we're attacking. So we might want to call it something different than just ballistic path, although I'm going to leave that for right now. We're going to add component spawn on button. We're going to give it our grenade and button name fire 1. And we want to set up our grenade so that it fits this. So, oh, sweet. 15 velocity change. Guess what? I actually didn't plan that at all, but that's exactly what we have for the velocity here. So that's awesome. So we have the grenade. It's already set up. So if that number was not 15, we'd need to change it to be the same number as our script. So force velocity change. So if we hit play right now, theoretically, when we shoot, we should see, well, we don't see a thing because this is colliding with ourselves and blowing up. So let's look at our grenade real quick. It currently does gib on collide, and so any collision it gets, it will blow up. It's under layer player projectile. So what I'm going to do is I'm going to put the first person controller under the layer player. And I think we've already set these up to not collide. Let me just show you how to do that though if they weren't set up. So if we go to project settings, physics, we can see in this that player does not collide with player projectile. So all we did was we unchecked this at one point. So if this was checked, we'd still have the collision problem. But now, when we fire, it should just fire. So if we shoot, it fires. Cool. And it looks like it's following that path. As I said, it's going to be offset by the 2 units, by the 1.33 units that we did. And that particle effect that it's using really should... I'm going to duplicate it so that we don't mess up another project. No, I'm just going to fix it because I'm pretty sure this grenade explosion should not be looping. There we go. Save scene, save project. So let's actually see how close it gets, just for right now. So I'm just going to fire one here, and then right before it hits, I'm going to pause and see how we're doing. So if we look at our grenade, it looks like we are really, really close to the path here. So if we step forward a few more times, that's looking pretty glorious. And actually, it's not offset to the left because we're actually firing it from that point. So it's actually offset to the right where but you'll see exactly where it's going to hit, so that's awesome. So it does seem like it is just slightly off, very slightly, but I think that's well within our tolerances for this example. So, so cool, we already have a ballistic path, and we can fire our ballistic weapon, but let's actually make it so that we can see where it's going to explode. So there's two scenarios where it's going to explode. We're going to explode after time, which we currently don't have, and we're going to explode on the impact point. So let's do impact point first, and then we'll look at adding time. So, because we already have the impact point stuff ready. So we're going to go to render ballistic path. And what we're going to be doing is called a ray march. So, remember when we did crosswalking before? Crosswalking probably isn't a real term. I think that I made that up for the show. I've never heard someone specifically use it, but maybe some people use it. Maybe someone came up with it at some point. But a ray march. Thank you. Ray march is a real jargon term. That's one that's actually in the industry, and it's what you do if you want to do a ray cast and then another ray cast and another ray cast, and you just kind of keep ray casting as you go. And the reason we need to do this is because we need to figure out the impact point of the ground, and so we are going to basically do a ray cast at each point to find out if we hit. Now, this is going to result in a lot of ray casting, so we may want to actually add... You might want to, if you're using this in a production environment, lower the... Let's actually first look at... So there's a very simple way we can lower the resolution of this. We can change the time resolution. So we can make this like... we made this 20.2. This will now result in a more angular-looking path, but it should still be pretty accurate. It's not going to be perfectly accurate, obviously. So if we shoot this thing and we hit pause, let's see how perfectly accurate. Yeah, you can see that it's actually a lot less accurate. So that may not be the best way. We might want to add a resolution thing that basically skips points here. But I'm not going to bother with that on this episode. Maybe some other time. So I just want to get this working first. So what we're going to do is, when we do this, we're going to do our raycast ray march. So we have our position, we set the position, we do the current position, we do the velocity vector, that stuff. So what we're going to do though is we're going to raycast from this position as well. So we're going to do if physics.raycast, and we're going to raycast with our transform, or wait, no, transform.position, no. We want current position, and we're going to cast in the velocity vector direction. And we're going to use a layer mask. I'm going to go ahead and add a layer mask here because that'll be useful. Public layer mask, layer mask. Actually, probably should do it that way. So now we're going to throw that layer mask in. And what else do we need? We need out. We need an output of some kind. So we need our distance layer mask. Okay, so hit info distance layer mask. So we're going to do out hit math f.infinity. Really doesn't need to be that long. Actually, we could probably make this the velocity vector. Actually, we want to make this the velocity vector. And layer mask. So that will be our raycast. And we're going to need our hit that we didn't actually define yet. So raycast hit. No raycast hit. That was my bad. Hit. So now hit, after hitting here, will contain what we need to do. So we're ultimately going to break out of the for loop here. The reason being is at this point we've hit the thing. We're not going to be needing the rest of the points that we had that were going through the world at this point. So we're going to break out, and that does cause one minor problem. Yeah, we'll see what happens. The only thing is we're setting the vertex count up here, and the vertex count will be actually shorter once we're done here. So actually, I guess we could just set it here. So we'll just do set vertex count to be whatever index is right now. Actually, we'll do index plus 1. Index plus 1. That's all we're going to do. And because we have this 1 that we've set here at index. And so the length would be index plus 1 because this is by 0, this is counted by 1. All right, almost done here. So all we need to do now is we want to render out an explosion. So I'm going to have a public game object explosion display. So we're going to instantiate the explosion display if it doesn't already exist. So we're going to have a reference to it too. Let's do private game object explosion display instance. So if explosion display instance does not equal null, then we will take explosion display instance equals hit dot point. Instance dot transform dot position equals hit dot point. So this will put it at where we hit. And then what else are we going to do? We should probably set... Oh yeah, we're not setting the final vertex here, so let's actually do this. We're going to actually have to do index plus 2. And we want to set position index plus 1 and hit dot point. So this will actually put the line renderer at the very final point. And what else are we doing? So we put the at that point, and then else we want to instantiate explosion display instance. Position is hit dot point. And we're going to use a sphere to show this, so I'm just going to use quaternion dot identity. As game object, and we're going to put it into our explosion display instance. And then we will, and actually we don't have to do anything else because it's already at hit dot point because of where we spawned it. So, yeah, this will work. I'm going to go ahead and wrap this in a if explosion display does not equal null. And the reason I'm doing this is if you needed this and you don't want the explosion display at the end, you could just not set it and it'll work. So let's see if that compiles. Number 4 can't convert to layer mask. Okay, so I must have messed something up on this. So if I do comma, oh, we didn't do the velocity vector dot magnitude. We wanted the length here, and so that's the length of what we want for the check. So, and we were getting some set out index out of bounds earlier. That's not good. Guess we should have looked for that earlier. All right, so now what I want to check here is we haven't put the instance thing, but does it actually just... Nope, it doesn't stop. Oh, and that's because we did a bad default for our layer mask. We want this to be equal to -1. This will not solve the problem, though, because if we go into the ballistic path here, you'll see that everything's set to... the layer mask is set to nothing. So I'm going to just set it to everything. Although, actually, we're going to remove player from it because we don't want it to hit the player. So here we go. We hit play. We pause. And we see that it is indeed stopping at the point that we wanted to stop at. Yay. So it's not traveling on below the point that we're impacting. So now we're just going to create a prefab that represents our explosion. So I'm going to just create a sphere, 3D object sphere. We're going to make a create a material, transparent red. We're going to make it red and transparent. So we're going to set this to 128. It's not going to affect the transparency yet, though, because this is normal diffuse. We want to set it to diffuse. Oh, we've got some new stuff. Diffuse, what is it called? Oh, yeah, it's under transparent diffuse. There we go. So now, and actually I'm going to make it a little bit more transparent. We're going to make it 75 or something. All right, so I'm going to put this on our sphere. We're going to make the sphere the size of our explosion. So our grenade currently explodes. I'm not going to be doing the airburst thing, like I said. It's not too hard to add that, though. All you would have to do is, in the case of, basically, if you get through the full for loop and you haven't done this stuff, you would just spawn it at the end there. And then you set the time to, the max time to whatever the time your grenade is. So, but what we're going to do here is, we've got grenade explosion. Add force on start. Does it actually... I guess it doesn't actually do an explosion, so we're just going to set the sphere to an appropriate size. We'll just make it 3, 3, 3, and 3. Let's just do that. That might be too big. So we're going to call this Ballistic Explosion Point or something. I don't know. And delete that from the scene, and then we're going to go to Ballistic Path and put that in for our explosion display. So if we hit play, the prefab you wanted instantiate is null. That's one I haven't seen before. Oh, whoops. Explosion display. Put the wrong thing in there. We want the instance to be set to that because the instance was null, so that was not going to work. So if we hit play now. Okay, it is working. That's funny. I like that a lot. So what is happening here is the explosion display instance has a collider on it and it's set to default. And so it's basically going to the point that we want. This is an interesting effect. And then the ray march is now actually hitting the explosion display, and so it comes back to us. And then as soon as it's inside, it hits the end again. That's really funny. So all we need to do to fix that is just to remove the collider that shouldn't be on this anyway. So we're just going to remove the sphere collider here and hit play. And we should see a place show where this thing is going to explode. So now we're still having the problem of if we have a grenade in air, it shows that we can hit the grenade. So I'm going to just fix that by removing player projectile from the list. So if we hit play now, when we fire, it goes to where we want it. Now, oh, it is actually applying this explosion force. Okay, that's good. But oh, I guess that's on the yeah, so we should make that sphere a little bit bigger because that's a big explosion. I'm going to make this 5, 5, 5. Took a little bit longer on this episode. I think it was worth it. Okay, so we do have one more bug I'm going to point out real quick that we should fix. If we move to the edge here, all of a sudden you'll see that even though we're past the edge, the ball is right there. And if we put it back in, it'll move. And the reason for this is, in the case where we don't hit anything, we don't do anything with the explosion display instance. So what we should do is, so if explosion display does not equal null, so if we don't hit else, if we don't hit, we will do, if explosion display instance does not equal null, then we will set the explosion display instance dot enable set active equals false, and we will do the same thing here. So if the explosion display instance does not equal null, then we do this true. And in this case, we will also, just in case, do it as well. So if we hit save now and hit play, we should see that we have the explosion instance still, everything's still happy, and if we get to the edge, it should disappear. And it did. Yay. And it should come back. Yay, everything's working. I don't like that it's not quite the same distance. It's like off by just a tiny bit. But it's close enough for what we're doing right now. Let's just watch it through. Maybe it's closer than I think it is. Yeah. Oh, we have a bug here. We have another, we introduce a bug. So you'll see at the end here, sorry, this is going overtime, folks. What's happening is the raycast is actually too long that we're using, so it's becoming this straight line at a point. The reason it's doing that is because we shouldn't be using velocity vector.magnitude. We should be using velocity vector.magnitude times time. Oh wait, not time. Delta time. We should be using the time resolution. I wanted to use time.delta time so bad, but it's not appropriate in this case because a frame hasn't passed. This is happening several times in a single frame. So if we hit play now, does that look a little closer? Ooh, that's looking real good. So I'm going to hit pause and go to game, or go to scene, find our ballistic path, wherever we are. Alright, so we're just going to watch these go, frame by frame, following the path real nicely, still following the path real nicely, still just a little bit shy, but I'm going to call it good. And the explosion blew the other one away. I like that. So let's save, call it a wrap. Thank you very much for joining us. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. Thank you for watching. If you can, please support us. Patreon.com/cookingwithunity. Even if you just put in $1 a month, that would really help us out. And you won't miss that dollar, I swear. And if you will miss that dollar, don't give it to us. But yeah, thank you very much for your support. Thank you very much for your time. And you guys have a great one. I'll see you tomorrow with another Breakfast with Unity.